Okay, so here we are. Another week's gone by. So the course is moving along rapidly, and we've got kind of a pace going where I've been putting in one assignment each week, and you guys have been submitting. Most of you are on track and doing well. A lot of you are still putting assignments in at the very last minute, and a few are, well, overstepping the deadlines. But so please. Do what you can to try to get things in as early as possible. But anyway, so here's next week's assignment. The main idea here is that we're going to just practice conditional statements a little bit more, but we're going to use a little bit different kind of graphical interface. What we've done in the past is just draw graphics, drawing rectangles and circles, ellipses. This time we're going to use some of the Java's prepackaged buttons and checkboxes and labels. There are a lot of applications that just you need to be able to type into a box or check some boxes, make some selections, hit some buttons. And rather than trying to create your own button class from scratch, and trying to make it work, Java's got some built-in stuff that is important to know how to use. So, so you can read the assignment. It's implementing the game of NIM, and I'm just going to go ahead and get started. So if I do a file, new, class, I've already got an assignment 12 here as for a new project, and inside of this project I'm just going to call this game of NIM. Whoops, it's not putting it in the right source folder, so I'm going to hit cancel. I'm going to go back. I'm going to make sure that assignment 12 is selected and try again. File, new, class. There it is, assignment 12 source. Okay, game of NIM. Finish. All right, and just like the other graphics applications we've done in the past, I'm going to extend JFrame. And I'll go ahead and have a public static void main string array args and inside of this I'll create an instance of the game. So I'm going to say game of NIM equals new game of NIM, and this should look a lot like the other projects we've done at this point. I'm going to set its size. This is going to be much smaller than some of the other ones we've done before. I'm just going to make this one 340 by 200. So g dot set size 340 by 200. We're not drawing a lot of stuff here. There's just going to be enough room for a label, a button, and a checkbox. So then g dot set visible true. Okay, and so if I just go ahead and run that, yeah, I want to save it. Oops. There's the errors. Alright, well, I can't run it yet. What is it not like? If I hover over the JFrame here for a second, it says I need to import JFrame. Okay. And of course then I get my warning, and so I'll use the quick fix and add a version number. What is it not like here? Oh, I didn't give it a name. G. Game of NIM G equals new game of NIM, and then G set size and set visible. Okay, I got rid of all the errors. Now let's just run it and see that we get a little box. There's my box. So my game is going to be inside of that box. Nothing too exciting yet. Um, Next thing I would like to do inside of the constructor, I'd like to create a constructor for my game of nim. So I'm going to say public game of nim, and I'm not going to give it any parameters. And so this is executed as soon as you create the new game of nim. And let's give it some instance variables. I'm going to need to have buttons in my game. So I'm going to add a private button. I'm going to call it submit button. And the idea here is that the person playing the game is going to choose how many sticks to pull off of the pile and then hit submit. And of course, if I've got a button, I've got to import the thing from the button. And so this declares the variable. The variable's not used yet. Let's go ahead and say in here something like submit button equals new button. And let's put some text on that button. So this declares the variable. This creates the object. I want to locate that button somewhere. So I'm going to say submit button dot set bounds. And buttons have all these different methods that we can use. It would take a lot of time to figure out all of them. I want to use the set bounds that specifies the XY location, the width, and the height. And I'm just going to put this thing at 20 over in the X. It's pretty close to the left-hand side. I'm going to put it 110 down in the Y, maybe about so close to the middle of the screen. I'm going to give it a width of 100 and a height of 20. Now, just because I've set its position doesn't mean it's visible on the screen. I'm going to start out by just saying this dot add. Well, actually, let's just hold off for a minute. I'm going to play that, and we can see that it'll compile and run, but nothing happens, yeah? Well, nothing any different. So there, the button is created, but nothing, I can't see it, I can't do anything with it. If I say this dot add submit button, so this refers to the game of nim, which happens to be a J-frame. And if I call the add method of a J-frame and add some sort of component to it, and a button happens to be a component, then it'll put it on that J-frames screen, that J-frames window. So now when I compile and run it, I should hopefully, there's my submit button. But the submit button is taking up the whole screen. What happened? I thought I set its bounds. Well, the problem is that the J-frame has a thing called a layout manager, and the layout manager tries to arrange things and set their size and everything, and it's ignoring the bounds that were already set up here. So what I've got to do is somehow change the J-frame so its layout manager, well, I'm just going to turn off its layout manager. The way to do that is I'm going to say this dot set layout, and I'm going to say null. So now I've got, whoops, I didn't get the right method. Now when I run it, there's my submit button, the size and location that I told it to be. That's good. Okay, what's next? Right now, nothing happens when I click the button, right? I would like some action to take place. So I've got to program that action in. The way to do that is I'm going to need to have an action listener, something that's listening for actions. So I'm going to add implements action listener. Of course, if I'm going to do that, I have to import action listener. And that's an interface. And as soon as I add implements action listener, that interface is a contract that's going to require that I implement certain methods. And so now game of nim says it's got an underline here. It says there's some error. If I hover over it, it says add unimplemented methods because we haven't satisfied the terms of the contract. So when I click that, it has added this action performed method down here. And right now, I'm just going to do something. I'm going to say system.out, .println hello world. And just because we got an action listener doesn't mean that we're actually listening for any actions. Nothing happens. So now I've got to make sure that this action performed method is going to get called when the button is clicked. So we've got to add an action listener to the button. So it has an add action listener method, and we're going to say this. So any class you create can implement the action listener interface as long as it creates an action performed method that looks exactly like this: public static void action performed action event E. So once you have something that is an action listener that implements the interface, you can add it to any button. Once you add it to any button, whenever they click on that button, the action performed method is called whenever the button is clicked. So if I hit play now, and I click submit, I get the words hello world. Okay, so that's good. I've got my submit button done, and it says hello world. Let's go ahead and add the other things to our screen, and then worry about filling in the details of action performed later. So this is going to be the behavior that happens when they submit their choice of how many sticks. But in order for them to be able to choose how many sticks, we're going to have some kind of checkbox or something. And so if I say private checkbox, I'm going to say 1, 2, 3. So we're going to have 3 checkboxes, and of course if we're going to use checkboxes we have to import the checkbox class. So this creates the variables 1, 2, and 3, which will hold our checkboxes. In the constructor we have to initialize those. So let's see, 1 is going to be equal to some new checkbox, yeah? So I'm going to say 1 equals new checkbox. And that checkbox is going to have some text next to it. I want that text to read 1. And then 1.setBounds. So this should position it on my screen. Let's put it at 20, 50 with a width of 120. A width of 100 and a height of 20. And then we're going to say something like this dot add 1 So let's see what happens. If I hit play, there's my checkbox. All right, good, I can put checks in it. Let's create 2 more. I'm just going to highlight these, copy, and paste. And then change, this is going to be 2, the variable that I spelled TWO. The label that's next to it, whoops, is going to say 2. I'm going to move this down 20 in the Y, so it's going to be at 70. And we're going to add 2 to our J frame. The third variable is going to be 3. Its label is going to read 3. We're going to set the bounds of 3. Whoops, I forgot to say 2.setBounds there. And its Y position is going to be 90, just 20 pixels below 2. And then we're going to add 3 to our screen. And we'll run it and make sure we've got 3 checkboxes, 1, 2, and 3. Except that I've got a problem. I would really rather that this would only allow me to check 1 at a time. What I really want is radio buttons. I want to assign these to a group. If I assign them to a group and they're all assigned to the same group, then Java will only let me check 1 at a time, and they'll be radio buttons. So what I need is a checkbox group. So I'm going to say private checkbox group. And we'll call this selection group. So that creates the variable, and if I'm going to use checkbox group, I have to, guess what, import it. All right. And so I need to say selection group equals new selection new checkbox group. And the way we add a checkbox to a checkbox group is when we create it. When we create it, we can either just give it a label, or we can give it a label and the selection group it belongs to, or the checkbox group that it belongs to. In this case, we called it selection group. And either a true or false, indicating whether or not it is selected when we first start out. And right now, I'm going to start things out with nothing selected. And I'm going to add all 3, one of my checkboxes, to the selection group. So now, hopefully, if we run it, oh, they look more like radio buttons. And guess what? I can only click 1 at a time. That's good. That's much better. All right. So what's next? Well, I suppose we should have some labels, right? So this is the game of NIM, and this game is going to have a pile of sticks, and we got to keep track of how many sticks are on the pile. We'll use an int for that. Private int stick count. And we're going to start out stick count as 21, right? Now, we should probably have some label on the screen that tells us how many sticks there are. So we're going to say private label, and we'll call that output label. And then we can say something like, okay, so this defines the variable. If we're going to use labels, we have to guess what? Import label. Yeah. All right. And then we're going to say output label equals new label. And then we got to give it the text that's going to be on the label. So I'm going to say there are stick count sticks. And then we need to add our label to our screen. So, oh, we need to set the bounds of the label. Output label set bounds. We'll put this label at 20, 10, and we're going to make the width 300 because it's got some text in it. It might be kind of long. The height is going to be 20. Just like the other things, we're just making the height of each one of our screen elements 20. And then this dot add the output label. So how does this work? There are 21 sticks. Okay. Still nothing happens when we hit submit, but we'll worry about that later. We should probably give another label that tells the person playing the game what it is that we want them to do. Now the output label I think we're going to change, but this label I think because each round of the game is exactly the same, this one won't change. So let's just define it right here, because anything out here are things that we're going to need to be able to access outside of the constructor. But here, we're just going to create the label, put it on the screen, and then it just stays on the screen forever after, and we never really need to access it in any other part of our program. So I'm just going to declare the variable and use it right here inside the constructor. So I'm going to say label. I'm going to call it the info label equals new label, and I'll say how many do you want to pick up. So there are so many sticks. How many do you want to pick up? Let us set the bounds. So info label dot set bounds. Let's put this at 20, 30 with a width of 300 and a height of 20. And this dot add info label. So let's see how that looks on the screen. All right, there are 21 sticks. How many do you want to pick up? 1, 2, or 3? And then submit. Okay, so the game doesn't really play yet, but we've really got the look pretty close. Let's scroll down and start working on the actions of the game. So one thing we need to do is we need to figure out which box was selected. So what we're going to do is we're going to say checkbox selected equals selection group dot get selected checkbox. And this, if we've got a group and we get the selected checkbox, it will return a reference to whichever checkbox happens to be selected. And so I'm going to say if selected double equals 1, then let's just print something to make sure that this is working before we do anything else. I'm going to say system.out.println 1. Else if selected is 2, system.out.println 2. Else if selected equals 3, system.out.println 3. Let's see if this works. So if I hit submit, nothing happens because nothing's selected. If I check 1, what happens? Oh, it prints 1 down here on my screen. If I keep hitting submit while 1 is selected, that's good. I'm going to select 2. If I hit submit, I get 2. If I check 3, I get 3. That's really good. So I know my action performed thing can determine which of the checkboxes is selected. That's really important. And it gets called each time I hit the submit button. So that's good. So we've got a lot of the framework in place. Now, I suppose if they selected 1, what we would like to do is we would like to take our stick count and subtract 1 from it. And if they selected 2, we would like to subtract 2 from it, and if they selected 3, we'd like to subtract 3 from it. Now, we would like to see the results of that on the screen. So what I would like to do is I'd like to say result label set text. So we're going to set its text to something different from what it already is. The result label, or we don't have a result label. We'll add that later. We want output label. Output label.set text. There are now stick count sticks left. Okay, so what's going to happen here? If we play it, if we hit submit, it says there are now 21 sticks left. It didn't subtract anything because we didn't have 1, 2, or 3 selected, but it did reset the output label. So there are now 21 sticks left. If I check 1 and hit submit, oh, there are now 20 sticks left. If I take 3 out of the pile, there are now 17. And I can keep going, and now I've got negative sticks. Uh-oh. Well, it'll be your job to make sure that the game ends when the last stick is taken from the pile. Let's see. What's next? what I would like to do is after they hit submit, uncheck the boxes. Because when we play this, if I hit 1 and submit, I would like it to take this out of 1, so I lose the selection. That forces them to think a little bit again about how many they're taking each turn. It makes them feel like this is a new turn. So selection group dot set selected checkbox to null. Null means nothing. So now if I run it, 1, submit, oh, it took the check out. 2, submit, oh, 3. All right, good. Now I think the computer should choose a move, right? So we're going to say something like int computer move. And the way I'm going to set it up is I'm going to just let the computer choose randomly, math.random. And math.random gives me a number between 0 and 1, not quite 1. If I multiply it by 3, it gives me a number between 0 and 3, not quite 3. If I cast that or convert it to an int, that chops out everything past the decimal. And if it's not quite 3, the biggest number that's to the left of the decimal point is going to be 2. It's going to be a 0, 1, or 2. But I want the computer to have 1, 2, or 3, so I just have to add 1 to it. So now this should give me a number between 1 and 3. So now what do I want to do? I would like to have a separate label that tells me how many sticks the computer picked up. Let's call that the computer label. We're going to have to create another variable, computer label. And let's see, in the constructor, we're going to have to initialize computer label. So I'm going to come down. I'm going to do that near the bottom, right before I do my submit button. Actually, I'm going to do it after my submit button. I'm going to put it in the code where I would visually see it. It doesn't really matter where in the constructor I do it, but I think just visually, if it's higher in my program, I'd like to put it a little bit higher in the constructor. I think it just makes things a little easier to find. So now I'm going to say computer label equals new label. And in the beginning, I'm just going to put empty quotes. I don't want this string to display, or this text, this label to display in the very beginning. So I'm just going to not give it any text until after the computer makes its first move. And then I'm going to say computer label dot set bounds 20, 150, 300, 20. So this is x, y, width, and height. And then this dot add computer label. So it exists, it's on the screen, but I can't see it because there's no text in it. That's fine. I'm going to add the text down here after the computer moves. So it'll be something like computer label dot set text to something like the computer picked up computer move sticks. So now when I play it, I'll be able to see how many sticks the computer picked up. 3. I picked up 3. Oh, this is off the bottom of my screen. Is that what I really want? I can resize my screen, but maybe I ought to just start my screen out a little bit bigger in the beginning. Or maybe I should put my computer label a little bit higher. I'm gonna make my screen a little bit bigger in the beginning. I'm gonna say set size 340 by 220. The computer picked up 3 sticks. Okay. Except that I picked up 3 and he picked up 3, but there are 18 left. That's not right. I forgot to subtract the computer's move from the stick count. So I'm going to do that after I set the computer label. I'm going to say stick count minus equals computer move. So I picked up 3. There were 21. I picked up 3. Oh, here's the problem. I set the label before I subtracted from computer move. So it still didn't show me what the computer took out. Okay. Let's just take this line of code and move it down to the bottom. So now if I play it, 3. I picked up 3, he picked up 3, it went from 21 to 15, so it decreased by 6, that's good. I would like to have something that tells me how many sticks there were after my move, and then I can see the computer picked up so many sticks, and then there are now so many sticks left. So I'm going to have something that I'm going to call a result label. I need another label. Go up to the top. And right here is where I've declared my labels. I'm going to add another label, result. And we'll come down here. Where should I put that? I'm going to put it right above the computer label. So I'm going to say result label equals new label. I'll start that one also out at blank. And result label dot set bounds. Let's put it at 20, 130, 300 by 20. We're going to say this dot add result label. And so now that label is sitting there ready for me to propagate it or fill it with text. So where am I going to do that? Right after my selection group, I'm going to say something like result label dot set text after your turn there were stick count sticks left. So now when I run this, There are 21 sticks. How many do you want to pick up? I want to pick up 3. After your turn, there were 18 sticks left. The computer picked up 3 sticks. There are now 15 left. That works out pretty well. I sort of feel like after moving, this ought to stand out a little bit. So what I'm going to do is I'm going to say, after my first move, I'm going to say output label dot set background color color dot yellow. So if I play it, what happens? Pick one, submit. See this grabs my attention now. I can see, oh, there are now 19 sticks left. That looks good. The computer picked up 1 sticks, plural. I don't like that. So what I'd like to do is I'd like to say, if the computer move was 1, then the computer picked up 1 stick, singular. And if it's otherwise, let it be sticks. Okay, so I'm going to say if computer move equals 1, else, and I'm just going to copy this line, and they're really exactly the same except for this one here is singular. So when I run it, I don't know how many times I'll have to do this. He picked up 3. Oh, he picked up 1 stick, singular. And then if I run it again, he picked up 3 sticks, plural. Looks like it's working pretty well. What happens if I hit submit and don't go? Oh, I can pass my turn. I think that would be cheating, right? Because I think the whole rules of the game of NIM is to try to force the other guy to pick up the last stick. And if I could just bypass my turn, then I could just, you know, when there's only 1 stick left up, go hit submit, and then the computer would be forced to pick it up. But that doesn't work for the game of NIM, does it? Let's do this. If they've selected 1, we remove 1 from, we reduce the stick count of 1 and do all of this. Otherwise, if they have selected 2, we reduce it by 2 and do all of this. Otherwise, if they have selected 3, subtract it 3 and then do all of this. I'm going to say else return. By adding a return here, it would quit. If it executes the return statement, it quits the action performed method. So if they have selected 1, subtract 1, and then resume execution down here and do all of this. Otherwise, if they have selected 2, subtract 2, and then resume execution down here and do all of this. Otherwise, if they have selected 3, subtract 3, and then resume execution down here and do all of this. Otherwise, meaning if they have not selected 1, 2, or 3, just quit and don't do any of this. That should work. That should force the person to take a move. So if I hit submit, oh, nothing happens. It's quitting because nothing is selected. I'm going to select 1. Now I've made a move, and so the computer then had to make a move. And now it's my turn again. I'm going to select 3 and hit submit. Okay, so that's working pretty well. What's next? I think I might be done. So what I would suggest is, while watching the video, hit pause every once in a while and go ahead and type in the code and try to understand everything I've done. And then your assignment is, my game has a label that shows how many sticks are left. The player is able to select 1, 2, or 3 sticks to pick up and click a submit button. The computer chooses 1, 2, or 3 sticks to pick up at random, and the appropriate number of sticks are removed from the pile and the player can go again. The features that you need to add to the game is to make the game end when the last stick is picked up. Make the computer make an intelligent decision if there are less than 5 sticks left. So the idea, if there are, if there are 3 sticks, if there are 2 sticks, the computer should pick up 1, yeah? If there are 3 sticks, the computer should pick up 2. If there are 4 sticks, the computer should pick up 3. What to do if there are 5? It shouldn't be too hard to figure out how many, I'll leave it up to you, the computer should pick up if there are 5 sticks left to force you to lose the game. Yeah, he can win if he has 5 sticks left. And then for extra credit, write an unbeatable game. If it starts out with 21 sticks and the player goes first, the computer goes second, it is possible to write the code in such a way that the computer always chooses intelligently and forces the player to lose every time. It's possible. It's hard. I should add one other thing that you need to do is prevent the player from taking more sticks than are on the pile. Okay? So essentially, if there are only 2 sticks on the pile, don't let the player select the 3 button. Yeah? If there is only 1 stick on the pile, then don't let him try to pick up 2. Just as a hint, there are things that you can do with buttons, right? Is there a disable? I don't know. If I type in oh, all right, that's a little much of a hint. So have fun and do your best. If you have any questions or problems, please let me know. Send me some questions in Canvas, and I'll do what I can to help you. Thank you.